Hello and welcome to ATI 4640. In this session, we will address capacity and constraint management to understand how the customer demand can be met and how to accommodate market changes. Capacity is the throughput or the number of units a facility can hold, receive, store, or produce in a period of time. Looking at the definition, we recognize some of the reasons why capacity is an issue. For example, the capacity can determine fixed cost, the cost that will be required to build and deliver the product. Some of the fixed cost examples will be addressed later on in another slide. So also it can determine if demand will be satisfied or will be met, which means can we produce or do we have the capacity to produce the proper amount that the market needs. To meet the required capacity, the organization has three options. We have long-term or long-range planning, intermediate term planning, and short-term or range planning. As shown in the figure, for the long range, all the planning will be within capacity modification with the purpose of expanding capacity through adding facilities and or adding long lead time equipment. While for the intermediate, the planning begins with modification of capacity through subcontractors, adding equipment or adding shifts, then utilizing capacity expansion by adding personnel. So at the beginning, we are not adding any machines or expanding in the facility, but we are trying to accommodate the demand using subcontractors and adding just certain equipment and changing shifts. In some cases, you might need to reduce capacity, which can be done through reducing shifts and reducing personnel. For the short range planning for capacity and meeting customer demand, we can schedule jobs, personnel, and allocate machinery to meet the required capacity, which means whatever you have on hand, you can use it, utilize it to meet the demand, and you will not be subcontracting, you will not be building new facilities or adding any new facilities. Usually we design capacity to be the maximum theoretical output of a system expressed in rate. But actually most of the time the capacity maximum cannot be even reached. Then how could it be done, or how it's done? The company or the firm has to define and measure their own capacity. So the effective capacity will be the capacity a firm expects to achieve given current operating constraints, which often lower than the design capacity. So if you are saying that the design capacity for a machine is 1000 per hour, 1000 units per hour, most likely the effective capacity will be less than that. While a process may have maximum capacity, many factors prevent us from achieving that maximum capacity. This slide shows an example of the design capacity of a machine or machines at Frito-Lay. The machines were built to produce 1000 bags of chips per hour, and the plant operates 16 hours per day. The design capacity for the machines can be calculated as follows. Design capacity will equal to 1000 multiplied by 16 hours of working. That's 16,000 bags that will be expected to be produced per day. Frito-Lay loses 3 hours of output per day. We have half an hour for preventive maintenance. We have 1 hour a day the employee breaks, and we have 1.5 hours for setting up machines and changing configuration for the different products that we have in the factory. So based on that, the effective capacity will be 16,000 bags per day. That's the one that we calculated, minus the 1,000 bags per hour multiplied by 3 hours that will be lost. And that will be 16,000 minus 3,000. So now we are left with 13,000 bags per day. And that's what we call the effective capacity. So although the design capacity for the machines is 16,000, the effective capacity is 13,000. There are other factors that will affect the machines, such as breakdowns and late part arrivals, which will count for another 15 minutes per day. Subtracting that from the total, we have the 0.25 hour, which is quarter of an hour. We have that multiplied by the 1,000, that's 250 bags. So we are losing another 250 bags from the 1,000, and then the total will be 12,750. So the actual output even less than the effective output that we expected. Based on the definition of both design capacity and effective capacity, we can define and calculate utilization and efficiency of the machines in the factory. Utilization is the percent of design capacity achieved, which is equal to the actual output divided by the design capacity, while the efficiency is the percent of effective capacity achieved, which will be equal to the actual output divided by the effective capacity. This is a bakery example that uses machines with design capacity of 1,200 rolls per hour. Since the bakery is operating 7 days per hour per week, 7 days per week, 3 hours shifts, the design capacity per week will be 1,600 rolls per week. The given effective capacity is 175,000 rolls per week, while the actual production of last week was 148,000 rolls, 148,000 rolls per that week, or for the last week. From the given information, we can calculate the utilization of the machines, which will equal the actual production divided by the design capacity of that machine. And based on the calculation and the numbers, utilization will equal 73.4%. So that's the utilization for the machines. In addition, we can calculate bakery efficiency through dividing the actual production by the effective capacity. Based on that, or based on the numbers, then the efficiency will equal to 84.6%. If the bakery management decided to expand their operations to include a second line, the design capacity will double to 403,200 rolls per week. The expected production of the new line is 130,000 rolls per week. So the effective capacity will also double to 350,000 rolls per week. And with the expected production of 130,000, the total production of the two lines will be 278,000 rolls per week. Calculating the utilization and the efficiency with the new expansion, we will find that utilization decreased to 68.95%. Of course, when you have an additional line, you are spreading the work on both lines, which will decrease the utilization of each line to 68.95%, which is, sometimes it's good to give you a chance for maintenance and for changes as needed. So since the load of production has been distributed on the two lines, the utilization will decrease. And the overall efficiency will also decrease to 79.43%. Capacity decisions, whether we are talking about long-term, intermediate, or short-term, will impact all 10 decision areas of operations management. Adding process, changing location to increase capacity, changing the layout to the new facility or to the same facility to even be closer to a supplier or closer to the market, partnership with other suppliers to ensure fulfillment, and many other decisions will be affected based on that. So for that reason, capacity decisions must be integrated into the organization's mission and strategy to begin with. When planning for capacity, the company must forecast demand accurately. Decisions could be made to fulfill demand through subcontractors and adding shifts instead of expansions and adding new machines until the company is sure of the constant increase of demand. At that point, the company will match technology increments to the sales volume. So the increments will not be used until you're sure of the sales volume that you have. An optimum operating size can be determined, but at the same time, the capacity will be built with a room for change. You need to give it flexibility of increasing or decreasing future changes. Having a large space is not always the solution. The large space might increase the average unit size, and the also small space might increase the average unit cost. So an optimum can be calculated to get the minimum average cost per unit through utilization or utilizing the right size or the right square footage. And in this chart, it shows that the 8,000 square feet was a lot. The 1,300 square feet was less or was not enough. So we calculated that and we got to the 2,600 square footage as our perfect space for the lowest cost. So again, you can tie that with the cost and see how when you divide the overall cost of the utilities and the space and other things, how would that tie to the average unit cost, and based on that you can make the decision for the proper footage. To manage and fulfill demand, we need to compare the company's capacity with the market or customer demand. There are three different scenarios. Demand might exceed capacity, capacity might exceed demand, and we might have like a fluctuating demand based on the season. And that will affect my planning for capacity, of course. So if demand exceeds capacity, then we can control or reduce demand by raising prices, scheduling longer lead time, or as long-term solution, the company can increase capacity, can add a new facility to increase capacity. If capacity exceeds demand, the market can be stimulated through price reduction and aggressive marketing. Of course, now you are making more than the market needs, so you need to push that to the market, and when you push it, you need to push it with marketing and maybe reduce the price a little bit so you can sell as much as you can. The company can also make some changes to attract customer through adding additional features or specs. So you can make product changes that can actually make the customer want to buy that product. If the demand is seasonal, we can use modules to produce a product that will fit with little adjustment into the different seasons. For example, snowmobile in the winter and the jet ski in the summer, most of the components are the same, except for a few adjustments that will be made between the two products to fit the different seasons. So if you look at the chart, this chart shows the variability in product of the snowmobile and jet ski sales, and how utilizing the same modules and combining the two demand patterns reduces the variation of sales. Some of the tactics that can be used to match capacity to demand is to hire more personnel and or purchase additional equipment to increase capacity, and selling or leasing existing equipment to decrease capacity. We can also analyze current processes and have a continuous improvement process in place to increase throughput. We can redesign products to facilitate more throughput through using modular designs or changing the material used or any other design related options to increase that throughput. When creating different product related processes, a flexibility should be added to each process to meet any future changes. So the variability, even if you change a little bit in the design, the process will still work and you don't need to change the processes a lot. So the process to begin with, when it was designed, it was flexible to accept any small variability in the design of that product. If the capacity still exceeds demand, the company can resort to the last option or tactic by closing some facilities if the capacity is a lot more and we cannot keep pushing to the market. The demand can be managed in the service sector through appointments, reservations, and the first come, first serve rule. To meet demand requirements and increase capacity of the service companies, we can hire full-time employees, temporary employees, and part-time staff. And this is what happened when you have the season of Christmas or Thanksgiving, and then we have a lot of demand on the services, especially in retail store or department store. So they will hire temporary employees just for that season until they meet the capacity and the demand requirement, and after that, they will have only their full-time employee available. Actually, looking at the production system, each work area or workstation can have its own unique capacity. The capacity of one workstation can affect the capacity of the whole system. To determine the throughput capacity of workstations, we can conduct capacity analysis. The workstation that has the most limiting factor or constraint is called the bottleneck. We can identify the time to process an item through each station. The total time to produce one unit will be called process time, and we're talking about the process time from station number one all the way to the last station, and that's what we call the process time. So the bottleneck time is the time of the slowest workstation, the one that takes the longest time in a production system, while the throughput time is the time it takes a unit to go through production from start to end with no waiting time. This slide shows an example of two identical lines that have two workers and three operations. Using capacity analysis, we can identify 5 different workstations or work areas, starting from the order all the way to wrapping and delivering process. As you can see in the figure, the two lines are identical, so parallel processing can occur. At 40 seconds, the toaster has the longest processing time, and it's the bottleneck for each line. When combining the two lines and assuming that the workers can use any of the available toasters, then the time will be 20 seconds per sandwich. Moving the bottleneck to the wrapping and delivery station with 37.5 seconds. Calculating capacity per hour based on the limiting workstation, we have 96 sandwiches per hour coming out of the whole system. The throughput time is 30 plus 15 plus 20 plus 40 plus 37.5, and that's a total of 142.5 seconds for the 1 unit to be out. So adding another wrapping person will increase the capacity to 120 sandwiches per hour. This slide shows another example of capacity analysis of standard process for cleaning teeth. From the analysis, we can see that cleaning and examining using x-rays can happen simultaneously. So from the analysis, all possible paths must be compared. The bottleneck is the hygienist at 24 minutes. The hourly capacity is 60 divided by 24 minutes. That's 2.5, 2.5 patients per hour. The X-ray exam path is 2 plus 2 plus 4 plus 5 plus 8 plus 6. That's 27 minutes total. While for the cleaning path is the 46 minutes per cleaning patient. Longest path involves the hygienist cleaning the teeth. Patients should complete in 46 minutes, and that will be the longest path for us. So what we did here, we used what we call theory of constraints, and we identify the bottleneck in each system. Once we identify the bottleneck, we will know what's limiting that system and how the output can be increased. With the throughput or output increasing, we can add resources or increase capacity using that method. If we're done with the bottleneck, the first bottleneck, we'll move on and we do another analysis to find another bottleneck, and so on until we increase the efficiency of the system and make sure that we are utilizing the maximum capacity that we can in that system. So from the previous examples, the theory of constraint can be identified as 5-step process for recognizing and managing limitations to the system. The steps are: first, we need to identify the constraints. Then we need to develop a plan for overcoming the constraints. Then focus resources on accomplishing step 2, which is the overcoming the constraints, and then reduce the effect of constraints by overloading work or expanding capabilities. Once overcome, we can go back to step number 1 and find another constraint and work on that, or find another limitation or bottleneck and work on that. And that's what we call theory of constraint. So to manage bottlenecks, we can release work orders to the system at the pace of set by the bottleneck capacity. We can make it as drum, buffer, rope. Drum, which is the frequency, the buffer, which is the control or the controls that we add to the system to manage the processes, and the rope is the communication between the different workstations and the flow of material between those systems. Lost time at the bottleneck represents lost capacity for the whole system. So increasing the capacity for non-bottlenecks station is useless and it will waste resources. Actually, it will not impact the system and it will not improve productivity, while increasing the capacity of a bottleneck will increase the capacity of the whole system. And that's again, based on our analysis for the bottleneck. With that, we will end up this session. So that will be all for this session. If you have any questions or concerns, please let me know. Thank you and have a great day.